Topic 3, Day 8, Trigonometric Function Transformations. So today we're going to focus on two functions, your sine function and your cosine function. And these sine and cosine functions are essentially what happens if we take our unit circle and then decide to kind of unfurl it so that our x-axis represents your angle measurement, and then your y-axis represents like the value, right? So the sine at pi is whatever value, 0 in this case. Okay, so when we look at sine, before any transformations, just our parent function, sine of x, there's kind of 5 important points that I want to show you. So sine at 0 crosses through our origin. And then we can see this wave pattern. And then at 2 pi, it makes it back to 0. And then it's just going to repeat over and over again. It's going to have that again and again and again every 2 pi. So we consider from 0 to 2 pi is 1 period, right? So from 1 period is 2 pi, right? And that's how long it takes for the pattern to go through one complete cycle before it repeats again, all right? For a sine function, at the halfway point of its period, it also crosses your x-axis again. In between the 0 and the first halfway point, if we go to half again, we make it to the very, very top. That's our maximum. And then in between the halfway point and at 2 pi, makes it down to our lowest point. All right, and then from there, our transformations can make this like stretched. It can kind of compress how long a period is, and it can shift up and down. All right, very similar to how our other our function transformations work. They follow much of the same rules. They might just look slightly different. All right, so again, keeping in mind sine follows this path. All right, now cosine is very similar, but at 0 is actually at its maximum value of 1, and then we'll go down and then come all the way back up. But the same kind of 5 important points are very similar, except now we're starting at our very top point, and then at pi in the middle, it makes it to our very lowest point, and then 2 pi, it makes it back up. And again, just like our sine function, it'll just keep repeating, right? Now, what I want to kind of show is that if we look at the cosine function from a different starting point, it looks identical to our sine function. So we can think of our sine and cosine functions as shifted left or right just a little bit of each other. But for example, if I look at it and start here, that makes our sine function, right? So it's just shifted over a little bit. And then our cosine function, again, crosses at like pi halves and 3 pi halves, all right? And if we were to take so sine of x, and then we can make our xy table. So it's 0, pi halves, pi, 3 pi halves, and 2 pi, right? If you calculate all of those sine values, we would get 0, 1, 0, -1, 0. If we do the same thing for cosine of x and y at 0, pi halves, pi, 3 pi halves, and 2 pi, right, we would get 1, 0, -1, 0, 1. Okay, we can calculate those both from our calculator and also from our unit circle. Now, when we have our different transformations, our letters A, B, C, and D will represent different ways that our trigonometric function can change. So your amplitude is the height from the center. Now the tricky part about the amplitude is you have to figure out where the center is. So you can find the center by taking the average of the highest and lowest points. All right. If there is no vertical shift, if it doesn't shift up or down any amount, the center should be at 0. However, if there's any kind of vertical shift, then you have to find the highest and lowest point and then find their average. And then from that point, how many units is it to the highest or lowest point? That is your amplitude. And your amplitude always represents your A value. The period of your trigonometric function is like how much does it take for your graph to repeat its pattern, right? So in order to find the B value, which is the related to the period, you need to do 2 pi over B equals the period. So in our previous parent functions, we talked about the period being 2 pi, right? So if the period is 2 pi, then we can calculate the B value by setting it equal to 2 pi over B and then solving for B, right? If your period is 4 pi instead, then again, you can set it equal to 2 pi over B and then solve for B, okay? If there is a phase shift, which is like shifting it left or right, please make sure your B is factored out in order to determine how much is shifted. And then your vertical shift D is moving up or down however many units. So let's take a look at teacher example number 1. It says, let f of x equal a cosine bx plus d for x is a subset of all real numbers where b is greater than 0. So here it tells us that we're looking at a cosine function, which makes sense because our highest point here, and then we're moving down, and then repeating this pattern. So we're going from 0 to pi. Our period is pi. Okay? It asks first for the value of A, which is our amplitude, right? So in order to determine our amplitude, we need to start by finding the midpoint. So 4 is our highest point, and then -2 is our lowest point, which means our middle is at 1. Now, our amplitude is a distance from the midline to the highest or lowest point, which is 3. So that means our A value is 3. We already talked about the period being pi because it, goes down and then up, and then that pattern repeats again every pi. So the period is pi. In order to find the value of B, we know that 2 pi over B is equal to our period, which in this case is just pi. So I can multiply B over 2 pi equals B pi, and then B has to equal 2. And now we have to find the value of D, right? And essentially our D value tells us how much our midline has moved up or down. And since it moved up 1 unit, right, from 0, our D value is 1. So go ahead and try student example number 1 on your own. Teacher example number 2. Here it says let f of x equal a sine bx. For where x is a subset of all real numbers, the following diagram shows part of the graph of x. So write down the amplitude of f. So again, amplitude is our A value. But here we can see that the lowest point and the highest point is -3 and 3, which means our midline here is at 0. That tells us that our amplitude is just the distance from 0 to 3, which makes it 3. And we know that A is our amplitude, so A also has to be 3. Now our period, we're looking for where does our pattern repeat. And for a sine graph, we're going to be looking for this pattern, right? So from 0 to 2 pi, which means it has a period of pi over 2. And in order to find the value of b, we're going to set 2 pi over b equal to pi halves. And since I set up this proportion, I can cross multiply. 4 pi equals b times pi, b equals 4. Go ahead and try student example number 2. Okay. Teacher example number 3. The following diagram shows part of the graph y equals p sine qx plus r. A, pi 4.5 is a maximum point, and B, 3 pi, 0.5 is a minimum point. Find the values of P, Q, and R. Now, this question is a little bit tricky because instead of using like our A, B, and C that we're used to, they use P, Q, and R. But we can kind of line up these P, Q, R values to our A, B, C values and use the same logic, right? So in this case, P is our amplitude, right? Q has to do with our period, which is going to be our B value. And then our R is our D value. All right. So in order to think about our P value, which is, again, representing our amplitude, we know that the midpoint between, 4.5 and 0.5 is going to be at 2.5. Right? And we can do that by just doing 4.5 plus 0.5 divided by 2. 5 divided by 2 equals 2.5. And the distance from 2.5 to 4.5, right, represents our amplitude, and that's going to be 2. So P is 2. Okay, this part gets a little bit tricky. So we know that going from the highest point to the lowest point, right, and then back to the highest point would represent one full period. But here it's only showing from pi to 3 pi is half of a period, which means our full period would have to be 4 pi. So if we know our period is 4 pi, then we can set that equal to 2 pi over b, right? And then I can multiply b on both sides, divide by 4 pi, and then we get b is equal to 1/2, which means q is also equal to 1/2. And then lastly, we have r, and r represents our vertical shift. So in this case, how much has it moved up or down from this, how much has the center line moved up or down from 0? And in this case, we went up 2.5, so we would say that r equals 2.5, or r equals 5/2. Okay, go ahead and try student example number 3 on your own.